Good day, everyone, and welcome you to class again. It's glad to know that you are still with us, and we are happy to see that you are always coming online to watch our tutorials. I will pray that the knowledge that you desire, the Lord will give unto you. Amen. So let's quickly take our confession before we continue with the lesson. Raise your right hand and repeat after me. My memory is blessed by the Lord. My understanding is enhanced by the Spirit of the Lord. My assimilation is accelerated by the Holy Ghost. And I excel in my studies. Amen. Thank you very much. If you did take that prayer, we trust the Lord that He will grant you understanding as we continue with today's class. Alright. Today we are taking Avogadro'S law. Avogadro'S law is one of the popular gas law that we have. You can remember we have Boyle's law, we have Charles' law. We also have Avogadro'S law, we have ID gas law, and so on and so forth. So one of the gas law that we are going to take is Avogadro'S law. If you remember one of our videos, I think two, we have recorded Boyle's law and Charles' law. So if you don't understand, you can equally go back and visit Boyle's law and Charles' law from our channel. Now, today we are going to take Avogadro'S law. We said Avogadro'S law states that at the same temperature and pressure, equal volume of two gases contain the same number of molecules, that is moles, of gas to be STP. STP means standard temperature and pressure. Now, so the mole of that has a volume called standard temperature and pressure, STP. So what are we saying in essence is that when we talk of Avogadro'S law, we are saying that if the same temperature and pressure, they will have equal volume. They said Avogadro'S law states that at the same temperature and pressure, equal volume of two gases contain the same number of molecules. So if temperature and pressure are constant, listen to me, if temperature and pressure are constant, then if we have equal volume of two gases, then their number of molecules will be the same. Their number of molecules will be the same. So in short, we say Avogadro'S law states that the volume of gas is highly proportional to the number of mole of the gas when temperature and pressure are constant. So when temperature and pressure are constant, the volume of a particular gas, of two gases, is very proportional to the number of the molecule, provided that temperature and pressure are constant. Alright, so let's quickly see the mathematical expression. So we said volume is highly proportional to the number of molecules, and of course we know that V now will equal to, we introduce a constant which is K, then N. So let's make K subject of the formula by dividing both sides by N. So N will cancel N, K now will be V over N. So now Avogadro'S law now states that when you have V1 over N1 will give you V2 over N2. This is the formula for Avogadro'S law. This is the formula for Avogadro'S law. So let's quickly take one or two examples as we continue with the class. Now let's quickly look at the example that we have. A balloon has been filled with a volume of 1.90 liter with 0.0920 mole of helium gas. If 0.0210 mole of additional helium gas is added to the balloon while temperature and pressure are constant, what is the new volume of the balloon. All right, solution. We said a balloon has been filled with volume of, so the first volume V1 is what? 1.90 comma liter. Then with 0.092 mole, so that's N1, 0.092 mole of helium gas. If N2 now zero point zero 210 mole, then we have to find the second volume. Alright, let's quickly solve the question that we have here. So this is the formula from there is V1 over N1. So we say V1 over N1 equal to V2 over N2. So we now have this to be what? We have gotten our V1, V2, N1, N2. So let's fix them. V1 is 1.90 L over N1 is what? 0.092 mole equal to V2. We don't know V2 over N2, 0.0210 mole. Okay, now of course we know from here we can cross multiply. So when we cross multiply, this will multiply this, this will multiply this, this will multiply this, this will multiply this. So we now have 0.092 mole times V2 equal to, this will multiply this, 1.90 L times 0.0210 mole. Okay, when you multiply this and this, you have 0.092 V2 equal to okay 1.9 times 0.02, so that will give us 0.038 L mole. Okay, so now to get our answer, of course don't forget this is mole, V2 mole. Then to get our answer, divide both sides by 0.092 mole over 0.092 mole. So this we cancel this, so mole will cancel mole. So now our V2 now will give us 0.038 divided by 0.092. So our answer is going to be 0.41 liter. So that's the answer. Of course, this is how simple Avogadro's law is. Okay, when our number of particles are not given in mole, maybe probably in gram, so I have to calculate it down to mole. We are going to see how to do that in while solving for ideal gas law. All right, so this is all about Avogadro's law from here. We hope you understand it. If you have any question, please notify us. Thank you very much. See you in the next video. Bye for now. Good day everyone, and you're welcome back to class. Let's quickly continue from where we stopped. Let's go to general gas equation. So general gas equation is also called ideal law or the ideal gas equation. It's also called the ideal gas law or the ideal gas equation. And this ideal gas equation is the combination of all the three other gas laws that we've talked about. So we'll combine Boyle's law with Boyle's law with Charles' law, then together with Avogadro'S law to make up ideal gas law. We make up ideal gas law, Avogadro'S law from Boyle's law, Charles' law. So we combine the three laws together to make up what? To make up general gas law. To make up general gas law or ideal gas equation. Now, to make the class easy and simple, these are the important things. There are some important things that we should note, and that is what we talked about here. Number one thing is that at standard temperature and pressure, temperature will always equal to 273 Kelvin. Pressure will equal to 1 atm, that's atmosphere. Then our volume is like 22.4 thereabout, because we can calculate it. All right, so just know that apart from ideal gas, if you are not dealing with ideal gas, at standard temperature and pressure is 7. When we have millimeter mercury, apart from ideal gas, when you are dealing with millimeter mercury, pressure is always equal to 760 millimeter mercury at standard temperature and pressure. And when we get to ideal gas equation now, our pressure at atmospheric condition, at atmosphere, our pressure is 1. So at 1 atmosphere, so that's our pressure. So let's understand that. Number 2 is that the number of molecule must be in mole. Yeah, I've seen some questions whereby you were given your number of molecule in gram, in mass, and same thing applicable to the one we just finished now, and that's Avogadro's law. If you are given your number in gram, in mass, we will first of all need to calculate it back to mole before we can make use of it. Now take for instance, if you are given a question and your number is in gram, if you use it like that, you are going to miss it. And that's why I want us to quickly see how to convert. I know we would have been taught, but I just want to remind us how to convert it now. Okay, so mole equal to mass over what? Molar mass. I think we are remembering now. It's mass over molar mass. Okay, let's quickly see some examples of what we are saying. Then don't forget that molar mass equal to the addition of what? Addition of all the atomic mass. Molar mass is equal to the addition of all the atomic mass. All right, let's quickly take some examples under this. Now we have gotten 2 examples on the board. Let's quickly see how they are solved. Solution. Number 1, we are told to convert carbon dioxide of 3.34 kg to mole. And don't forget our formula. We said mole equal to mass over molar mass. Now, first, carbon dioxide is CO2. So, let's do the molar mass for CO2. All right. So don't forget that C, the atomic mass of carbon is 12. Then atomic number of oxygen is 16. Now if this is this, then we can now continue and say molar mass now will give us how many molecule of carbon is 1. That's 12 plus there are 2 molecule of oxygen, 16 times 2. So that will give us 12 plus 32, that's 44. 44 gram per mole. Okay. So let's now go and find our mole. Our mole will give us, what's the mass that we are given? 3.34 gram over 44 gram per mole. Then gram will cancel gram. We have, of course, you know this one will come up 3.34 mole over 44. So by the time we divide 3.34 by 44, we have 0.76 mole. I think we understand that. So that's how to calculate that. Let's take example 2. The same thing. 3.72, that's a gram of NaOH, that's sodium nitrite. That's sodium nitrite. So sodium nitrite, that's NO3. Then for the what is atomic mass of nitrogen? 14. Yeah. Then atomic mass of oxygen is 16. So now, how many molecules of nitrogen do we have here? We have 1. So that will be 14. Plus how many molecules of oxygen? That's 16. So that will be 14. Plus, this is 8. 18. Keep 1. 3, then 48. Then our answer is going to be 62 gram per mole. Okay, so our mole now will give us our given mass, which is what? Number 2. 3.72 gram over our molar mass, 62 gram per mole. Then gram can cancel gram, mole will come up to give us 3.72 mole over 62. So by the time we divide 3.72 divided by 62, our answer will give us 0.06 mole. So this is how to convert from gram to mole. You can see how easy and simple it is. Now, let's go and see other things that we need to put into cognizance before we go into some examples. All right, this is the third thing that I think I said we should note before why is tackling problem that has to do with general gas equation or ideal gas equation. All right, the third one I said ideal gas is obtained by the combination of all other gases. So therefore, ideal gas equation is given as Boyle's law is V directly proportional as the inverse of K of P. Then Charles' law says that V is directly proportional as temperature. And Avogadro's law states that volume is directly proportional as what? As the number of particles. Now, combining the three, ideal gas now will be what? Ideal gas now will be V is directly proportional as 1 over P directly proportional as T, n directly proportional as N. So that will give us V directly proportional as what? T N over P. I hope you understand that. So now this proportionality sign will change to equality sign. So when it changes, we will introduce a constant. Let the constant be R. So now V now will equal to, we introduce a constant T and N over P. You can rearrange this, then you have your V to give us N R T over P. So from here we can cross multiply. By the time we cross multiply, we have VP, or better still, we have PV equal to nRT. So this is the formula for ideal gas equation. This is the formula for ideal gas equation. I hope you understand that. All right. Of course, we know we can work around this. We can get our hand, make any subject of formula, make any of this subject of formula, but this is the formula. Okay, let's quickly explain the fourth thing that I said we should note before we take these three examples and call it a day. Number 4 is that our R in the formula is 3. It can be 8.31 joule Kelvin per mole, or 0.082 LATM mole per mole Kelvin. All right. Now, when do we use this R and when do we use this R? Number 1, when you are given your pressure in Pascal. When your pressure in the question is given in Pascal, you use your R to be 8.31. But when your pressure is given as ATM, that's atmosphere, you use your R to be 0.082. Of course, there are ways to convert other types of other measurements of other ways of measuring pressure to atmosphere, but we'll take that in subsequent video. All right. When you have your volume in meter cube, you use 8.31, but when you have your volume in liter, you use 0.082. Then when you have your temperature in Kelvin, you can use this. When your temperature is in Kelvin, you can use this. So temperature is not part of what you can use to decide either to use R equal to 8.31 or R equal to 0.082. But other conditions, either pressure, when you are given pressure in PA, Pascal, then you use 8.31 joule Kelvin per mole. Then when you are given your volume too, you use this. So when you have your temperature in atmosphere, ATM, then you use this. Then when you have your volume in liter, you use this. I hope you understand that. All right, let's quickly go down to the examples that we have. All right, let's quickly see the solutions. Number 1, what's the volume occupied by 2.32 gram of carbon dioxide as at STP? Don't forget I told you the meaning of STP the other time. STP means standard temperature and pressure. So at standard temperature and pressure, when you have your volume, you can calculate the volume that is occupied. So N now is what? Don't forget our formula. N is what? 2.32 gram. You can see that our N is given in gram. So because it's given in gram, we are going to calculate it, we are going to convert it to mole. I hope you understand now. Because it's in gram, we convert it to mole. Alright. Do we still remember how to calculate to mole? So we say mole is what? Mass over molar mass. Okay. So how do we calculate the molar mass now? Molar mass of what? Carbon dioxide, that is CO2. Alright, so carbon has the atomic molecule of what? We said 12, plus oxygen has the atomic molecule of 16, but it has 16 molecules, 2 molecules. Okay, so we have 12 plus this times this, that's 42. By the time we have 44 gram per mole. And let's come back and put mole now. Let's put it there. The mass that we are given is 2.32 divided by 44 gram per mole. This is mole, and this gram. So this gram will cancel this gram. Then you know this per mole, then the mole will go up. So you have 2.32 mole by 44. And by the time you use 2.32 to mole divide 44, our answer is going to be 0.052 mole. I hope you understand that. Alright. Now we have gotten our M to be 0.0523. Don't forget that I told us that we have to find P. That's what we have to find. Oh, sorry, we have to find V. We have to find the volume. We have to find the volume. You don't know it. Our N now is what? 0.0523. 0.0523 mole. Then don't forget I told us that R that we're going to use is what? 0.082. Then T at STP, standard temperature and pressure, is 273 Kelvin. Then pressure is 180 P. If you see, remember that's the first rule. This is the first rule that I said you should notice. Alright, then this is the last one, the table I gave. Because our pressure is in ATP, atmosphere, and we don't know volume anyway. So let's quickly solve using this formula now. Let's make use of your formula here. That will be nRT over what? P. Of course, you know from here we cross multiply. P will cancel P, then you have, except divide both sides by P. P will divide P here, P will divide P here, so P will cancel P. We have only V and this. Alright, let's quickly slot in our formulas, our figures. 0.0523 times 0.082 times T, 273K over the pressure, 180 P. The pressure is 1 at standard temperature. I believe I told us that as well. By the time you multiply this, and this, our answer now is going to give us 1.19 liter. Do we understand it? Alright. Number 2. Calculate the temperature at which, here is the number, 0.654 of neon gas occupies volume in liter, 12.30 liter, at pressure 1.95 atm. And don't forget I told us when we have atm we are using this. Okay, so let's quickly plug in our formula. What are we looking for? Calculate the temperature. You have to calculate C. So let's make this of your formula from the formula. So let's make this your formula from the formula. So we have that by NR. This will cancel this. T will equal to PV over NR. So do we get that now? So let's quickly sort this into this. So now, what's P? 1.95. What's V? 12.30 over what's N? 0.654. What's R? 0.082. So by the time I use this to multiply this to multiply this,